to Physical Science 4.2 on Ohm's Law. It is 2023. First of all, let's talk about the Ohm's Law formula. V is equal to IR. V stands for voltage measured in volts. I stands for the current measured in amperes. And R stands for the resistance measured in ohms. The relationships between those, voltage is directly related to both current and resistance, but current and resistance are inversely related to each other. You do have the equation alternatives where you solve for current, which is voltage divided by resistance, and resistance is voltage divided by current. Let's add those to your formula sheet now. Voltage, V is equal to IR. Volts can be abbreviated V. Current, I is equal to V divided by R. In amps, can be abbreviated lowercase a. And resistance, R is equal to V divided by I, measured in ohms, can be represented by the symbol omega. So here's a breakdown of Ohm's law. You should really put this in some notes. The definition of resistance is the opposition to the flow of current. Its symbol in the equation is R. R is equal to V divided by I. Current is the flow of the electrons through that circuit. Its symbol is I, and its equation is I is equal to V divided by R. Voltage is the potential difference or the push behind the electricity. Its symbol is V, and its equation is V is equal to I times R. Continuing this text, units, resistance is measured in ohms, and it depends on the size, the thickness, and the length, and the material it's made of, like we learned last time. Current is measured in amps, or amperes, and the resistance of the current is inverse relation. The greater the resistance means less current. So there is a definite connection between current and resistance. The voltage is literally the voltage source, and it depends on how strong your voltage source is, whether it's a new battery or an old battery or 3 batteries together. The implications of Ohm's law are these. For a given resistor, the greater the voltage, the greater the current. The resistor and the battery dictate the amount of current that flows. For the same battery voltage, a larger resistance will draw a smaller current, while a small resistance will draw a large current. It's an inverse relationship. Ohm's law applies to resistors. Ohm's law is useful to figure out not just one thing, but 3 things, and it can be applied to individual things, strings, or an entire circuit. So let's look at a series circuit. A series circuit has the same current flowing through each part. The total resistance is equal to the sum of the individual resistances. The voltage is applied is equal to the sum of the individual voltage drops. The voltage drop is proportional to the size of the resistor. And if the circuit is broken or open, no current is going to flow because they all flow through each other. On your formula sheet, give yourself a summary of series circuits. The current is the same everywhere. Voltage drops across each resistor, and the total is the sum of the voltage drops. Resistance is the total of the sum of each individual resistor. Let's look at an example of a series circuit. Notice this series circuit has one battery that is 6 volts and then 3 resistors. Could be 3 anything. There are 3 resistors, each of a resistance of 4 ohms. That means it has a total resistance of 12 ohms because 4 times 3 is 12. And total voltage of 6 volts. So what is the current? Well, if we look at the series circuit as a whole, the current is equal to the total voltage divided by the total resistance. 6 divided by 12 should give us a current of 0.5 amps. Notice in the graph, we can apply this to each individual resistor. If I wanted to find the current going across this resistor, or the voltage drop, voltage is current times resistance. So this voltage is going to drop by 2 volts, 2 volts, and 2 volts. So if I graph the voltage versus the location at position A, right after I leave the negative side of the battery, at position A, I have 6 volts. As soon as I get to B, I still have 6 volts. Once I go through B to C, the voltage is going to drop by 2 volts. From C to D, I keep all 4 that I have remaining. From D to E, it drops again by 2. E to F, I keep it. F to G, it drops again the next 2. And from G to H, there is no voltage available. Let's look at another example. This one has a voltage, 2 resistors, and you can see how the voltage drop was graphed. The 2 resistors, resistor 1 is 10 ohms, and resistor 2 is 5 ohms, and they're connected in series to a 6-volt battery. The total resistance is 15 ohms. What is the voltage drop across the 10 ohm resistor? Well, if you had to use math to do it, the first thing we have to do is find the current. Current is voltage divided by resistance. So 6 divided by 15 would be 0.4 amps. Then I use that knowledge to find the voltage drop across the 10 ohm resistor to be 10 times 0.4 or 4 volts. 5 times 0.4 is 2 volts. So I drop 4 across the 10 ohm resistor and 2 across the 5 ohm resistor. Let's talk about parallel. Parallel has 2 or more paths for the current to flow. The voltage is the same across each branch of the parallel circuit. The sum of the currents through each path is equal to the total current that flows from the source. The resistance is equal to the reciprocal of the sum of the reciprocals of each resistor. It essentially means take 1 divided by resistor 1 plus 1 divided by resistor 2 plus 1 divided by resistor 3, and you'll get an answer. And then flip that answer over, and you'll get the total resistance. This is why in testing we found that the resistance decreased, the total resistance was smaller in parallel than it was each individual branch. If one path is broken or open, the current will continue to flow through the other paths. This is hopefully how your house is wired. So on your formula sheet, I want you to add this summary. Current is individual through each branch. The total current is the sum of the currents of each branch. Voltage is the same across each branch, and the resistance of each branch is individual, but the total resistance is the reciprocal of the sum of the reciprocals of the individual resistances. Let's look at a couple examples. Kara connects 2 bulbs with resistance 2 ohms and 3 ohms in parallel across a 12-volt battery. What is the total resistance? How much current is drawn from the battery? So total resistance is 1 divided by RT, right? 1 over RT is equal to 1 over R1 plus 1 over R2. So this would be 1/2 plus 1/3 is 5/6. But then you flip that over. RT is 6/5, which is 1.2 ohms. The total resistance is lower than each individual resistor. The current drawn from the battery is the total voltage divided by the total resistance. 12 divided by 1.2 gives us a total current of 10 amps. We could continue this and find the current through each branch because that is separate. If Kara connects two bulbs with resistance of 2 and 3, branch 1 gets 12 volts because it's the same in each branch. It has 2 ohms of resistance, so it gets 6 amps of current. Branch 2 has 12 volts and 3 ohms. It gets 4 amps of current. The total current is 10 amps. You're going to be doing lots of problems. Thanks for watching.